y'all. Today we're going to talk about how to solve square root equations. So we're going to see a couple of different types of ways these problems may be presented and how we will go about solving each scenario that we come across. Okay, so we're going to work first on this problem right here. 5 plus the square root of x minus 3 equals 9. So you'll notice initially on this problem, the only variable we have is underneath our radical. Outside our radical, we only have constants or plain numbers. So our first step in solving this is going to be to isolate the radical, isolate the square root. And anytime we're solving for a variable, we're going to work backwards order of operations. That's just a reminder of things we've done previously. So we're going to start at the bottom. We're going to move anything that needs to be added or subtracted first. So I'm going to do that by subtracting 5. The left side zeroes out. I'm left with the square root of x minus 3 equals 4. So our radical has been isolated. Our next step to get rid of that radical would be to square both sides of our equation. So when you square a square root, they cancel out because they're inverses of one another. So on the left, I'm left with x minus 3 equals 4 squared is 16. So x minus 3 equals 16. And then we're just going to go about solving like we normally would. So I have x equals 19 as my solution. Okay, step 4 says verify our solutions and check for extraneous solutions. So just like we did in absolute value equations, we're going to potentially have extraneous solutions that don't work when we plug them in. So we always want to plug in our answer to the very original equation we started with. So up here at the very top. So I'm going to plug in, we have 5 plus square root of 19 minus 3 equals 9. So we have 5 plus the square root of 16 equals 9. Square root of 16 is 4, and 5 plus 4 does equal 9. So we get a true statement. Therefore, we know x equals 19 is a real solution. It's something that works when we plug it back in. Okay, you can try it by graphing it on your calculator. So if you have a TI-84, you would enter the left side and the right side into your y equals. So you would say y equals 5 plus square root of x minus 3. And then in your second y equals, you would enter the right side. You would say y equals 9. And as we know from previous units, the solution is going to be where those two things intersect. So it says once you put those in your y equals, you're going to hit second trace 5. And that's going to be 5 stands for on your list the intersection. Okay, so this is going to be on a TI-84. Of course, we could also do it on Desmos. So I'm going to first type y equals 5 plus square root of x minus 3. And then we said for our second one, we wanted to type y equals 9, the right side of that equation. Okay, and we're looking for an intersection. I see an intersection right here. So I'm going to tap that. And I see that it occurs at the point 19, 9. So remember, your solution is always the x value from that ordered pair. Okay, so looking at the second example, we've got the same scenario. So no variables outside the radical. We're going to start by isolating our radical, getting this by itself. So I'm going to add 3 to both sides. This side zeroes out. Square root of 2x plus 5 equals 5. And at this point, we're going to square both sides of our equation. We're left with 2x plus 5 equals 25. So I'm going to subtract 5. We get 2x equals 20. Divide by 2. And we find out that x equals 10. So then I'm going to take that value of 10 and plug it back in to my original equation. So square root of 2 times 10 plus 5 minus 3 equals 2. We're going to solve what's under the radical first. 2 times 10 is 20, plus 5 is 25. Square root of 25 is 5. And 5 minus 3 does equal 2. Okay, so we know that that solution x equals 10 does work. It's a real solution, not an extraneous one. So now we're going to take a look at a couple of special situations. Okay, the first one we want to look at right here is when we have two square roots in the same exact problem. So this one is going to work out really nicely because we see a subtraction sign between them and we see a 0 on the other side. So what we're going to be able to do is split up our two square roots and have nothing besides the square root on either side. So our first step would be to isolate both of the radicals. So I'm just going to add this term to both sides, square root of 8x minus 5. So this zeroes out. We have square root of 3x plus 5 on the left, and we have square root of 8x minus 5 on the right. So now that we've got both radicals isolated on their own side without anything else, our next step is going to be the same. We're going to square both sides, which cancels out the radicals. We're left with 3x plus 5 equals 8x minus 5. And from here, we're going to just solve for our variables. So we're going to get our variables on the same side. I'm going to take my x's to the left, my constants to the right. Whoops. So we end up getting negative 5x equals negative 10. When we divide by negative 5, we get x equals 2. Okay, of course, we want to check and make sure that that's not an extraneous solution. So we're going to take it back up to the top and plug it in. Square root of 3 times 2 plus 5 minus square root of 8 times 2 minus 5 equals 0. So here I've got 6 plus 5 is 11. So square root of 11 minus 8 times 2 is 16 minus 5 is 11. So square root of 11. Oops, and we want that to equal 0. So we don't even have to take the square root of 11, thankfully, because it's not a perfect square. Anytime you have something minus itself, you're going to get a 0. So square root of 11 minus square root of 11 equals 0. So this answer does check out. Okay, our other special situation that we're going to look at is when we have one square root that has a variable inside, and then we also have another variable on the outside of a square root. So we still want to start this problem the same in the fact that we want to isolate our radical, which it looks like in this problem, it's already been done. So I've got my radical on the left all by itself. Everything else is on the right. So step 2 is still going to be the same. We're going to square both sides. So on the left, my radical and my square term cancel out, and we get 2x plus 10 left over. On the right side, we're going to have to do some distribution because we have x plus 1 squared, or x plus 1 times x plus 1. So if you distribute that out, FOIL it out, you end up getting x squared plus 2x plus 1. You would have to distribute everything in the left term to everything in the right term. So now we have this quadratic equation. We have an x squared term in our equation. So we're going to have to get it in standard form and solve that way. So I'm going to get everything on the x squared side. So I'm going to subtract 2x, subtract 10 from both sides. So the right side zeroes out. On the left side, I'm left with x squared. My 2x is actually 0 out. And then I have minus 9 equals 0 because everything is on one single side. So from here, we are going to solve for x. So we have a lot of methods for solving with a quadratic. You can solve it by graphing. You can solve it by quadratic formula. You can solve it by factoring. This one in particular, we're just going to be able to solve by moving our values around because we don't have a center x term. So for this particular problem, we're going to be able to just add 9 on both sides. We have x squared equals 9, and then take the square root. We get x equals, remember, anytime we take the square root of a value for our solution, we have to put plus or minus. So we have two solutions, x equals +3 and x equals -3. So when we plug in to check for extraneous solutions, we're going to have to plug in two values. So I'm going to start with a +3. Square root of 2 times 3 plus 10 equals 3 plus 1. That's my x value. So here I have the square root of 16 equals 3 plus 1, or 4. Square root of 16 does equal 4. So now we're going to plug in our -3. So I have the square root of -3 times 2, or 2 times -3, plus 10 equals -3 plus 1. Now, when we're plugging in our values to check our work, this is going to be square root of 4 equals -2. Even though up at the top I told you we're going to have to take the plus or minus value when we take the square root, down here, we're only going to be considering the positive value when we check for extraneous solutions, and that did not work. So we would say our solution for this problem is just a +3. So I know that's going to be a little bit confusing, but when we're algebraically solving a problem, we want to consider both the positive and the negative values when we take the square root. But when we're plugging it in and we're checking our work, when you take the square root, you're only checking for the positive value when you're looking for an extraneous solution. So in other words, we wouldn't say plus or minus 2, -2 equals -2. Because if we come over here to the graph, I've graphed both the left side and the right side, square root of 2x plus 10 and x plus 1. You see that there's only one intersection. Okay, that x plus 1 is a linear function, and then the square root of 2x plus 10 is a square root. So you see that x equals 3 graphically is our solution.